Hello, so today we're going to be talking about function analysis. So this is how we're going to connect the original function to the derivative to the second derivative. So first let's start easy with a polynomial function. Okay, look to see if you have any asymptotes. You do not, because it's not a rational function. There's no square root, so your domain is negative infinity to positive infinity. Okay, now you're going to check your x-intercepts. This is setting the function equal to 0. Greatest common factor. Okay, zero product property. Okay, y-intercept. Is going to be 0. 0 cubed minus 4 times 0 is 0. So looking at the graph right now, we have this. Okay, and then we can look at the end behavior of this. Alright, so this is down on the left and up on the right. Okay, so this is telling us we're not going to have any absolute extremum. Okay, next let's look to see where it's increasing, decreasing, or where local extrema is. So we do that by finding the first derivative. Set that equal 0. So we're looking for a critical point now. So that's going to be 4 thirds plus or minus square root of 4 thirds equals x. Add 4, divide by 3, square root both sides. Then you get plus or minus 2 over the square root of 3. Rationalize your denominator. So that's going to be the value you're going to be testing. So we got negative 2 root 3 over 3. Oh, and this is going to be around negative 1 point, plus or minus negative 1.15. So we got negative infinity to negative 2 root 3 over 3. Then we have 2 root 3 over 3. Negative 2 root 3, negative 2 root 3 over 3 to 2 root 3 over 3. And then we have 2 root 3 over 3 to infinity. So now you got to check your intervals. Pick a number between these two numbers. I'm going to choose negative 2. F prime of negative 2. Okay, so that's going to be 3 times negative 2 is going to be a positive. So that's going to be 3 times 4 minus 4 is going to be a positive number. Then going from negative to a positive here. 0 is the easiest one to use. You got 3 times 0 minus 4, which is a negative. And then you have f of 2. Oops, that's squared. 3 times 2 squared minus 4 is a positive. So we do have critical points here because it's increasing and decreasing, and then decreasing and increasing. So we're going to have a local max here and a local min there. Let's look at increasing and decreasing values first. So it's increasing from negative infinity to negative 2 root 3 over 3 union 2 root 3 over 3 to infinity. You just look to see where they're both positive. Decreasing from negative 2 root 3 over 3 to 2 root 3 over 3. Okay, local max is going to be at negative 2 root 3 over 3 and it's going to be positive 3.08. Okay, so what you do, you put this number in here, evaluate it, or so you could either put the graph in and trace it. That's what that is. So it's C negative 1.15, you get 3.07. Or you can do negative 2 root 3 over 3. I think that was supposed to be squared. I gotta put a 3 here. Oh, times 3. Oh, never mind. Never mind. Minus 4, negative 2. It would be easier if you just do this. 2 root 3 divided by 3. Get that number, and then do second answer cubed minus okay, that's another way. All right, so that's going to be for the positive. The negative one will be the opposite one. Negative 2 root 3. So okay, that's the one we got. All right, so I went ahead and found the other one for you. That's negative 3.08, and that is a local min. Okay, so right now we got negative 1.15, 1, 2, 3, 1, 2, 3. So about here. 1. So you got a max and a min. Now point of inflection is going to be the second derivative. Okay, second derivative of that is going to be 6x. Set that equal to 0. You get x equals 0. So now we're determining where it's concave up, concave down, and if there's a point of inflection, which is where the concavity changes. So you have negative infinity to 0, and then 0 to infinity. F double prime of negative 1 is going to be 6 times negative 1 is going to give you a negative. F double prime of 1, 6 times 1 is going to give you a positive. So it's concave down from negative infinity to 0, and it's concave up from 0 to infinity. Point of inflection is going to be at 0, f of 0, which is going to be 0. So it's increasing from negative infinity to negative 2 root 3. Local max there. Changing concavity at 0. Decreasing from negative 2 root 3 to 3, and then increasing from 2 root 3 to 3. And there's your graph. Okay, next example is going to be a rational function. So we have f of x equals x over x minus 2. Okay, check your domain. So you got a radical. I mean, not a radical. You have something in. So the numerator's fine, the denominator's not. So x minus 2 can equal 0. X can equal 2. Okay, so this is telling you two things. It's telling you what your vertical asymptote is and what your domain is. Your domain. So your vertical asymptote is this. Your domain is going to be negative infinity to 2 union 2 to infinity. Okay, let's see if we said we got a horizontal asymptote as well. You look at the degrees here. The degree of the numerator equals the degree of the denominator. So you're just dividing by the coefficients. So there's that chart if you need it. The numerator degree equals the denominator degree. So that's going to be y equals 1 over 1 okay. So right now for our graph we have this. Oh, x-intercepts. X-intercepts real quick. It's going to be when y equals 0. So I just usually set the numerator equal to 0 because when you do x minus 2 times 0, that's 0. So x equals 0. Y-intercept is going to be at f of 0, which is also 0. Okay, so that's our graph right now. Now we're going to see where it's increasing, decreasing, or any extremas happening. Okay, so f prime of x, use the quotient rule, where f is x, f prime is 1, g is x minus 2, g prime is 1. So that's going to be f prime of x minus g prime of f. Over g squared. Set that equals 0. 0 equals negative 2 over x minus 2 squared. So for these, you got to check the top and the bottom. For zeros, set the numerator equal to 0. Okay, so there's no like 0 values. Undefined, x minus 2 can't equal 0. Okay, now if you remember from the beginning function, our horizontal asymptote, our vertical asymptote was at x equals 2. So there's probably not going to be a max and min here, but we're still going to be learning where the graph is increasing and decreasing. So negative infinity to 2, f prime of 0. Okay, so you're going to have a negative over a positive. The bottom's always going to be a positive because of the square. So that's going to give you a negative. 2 to infinity, that's f prime of 3. That's also going to give you a negative, because that's negative on top, over a positive. Okay, so there's no extrema, absolute or relative, but it's decreasing from negative infinity to 2, union to the infinity. Okay, now let's check concavity, going to the second derivative. Okay, so I'm going to start with the first derivative here. I'm just going to write it differently. I'm going to do negative 2, x minus 2 squared to negative 2. Chain rule. Take down the power, so negative 2 times negative 2 is positive 4. Take the derivative of the n sub, which is going to be 1, and then subtract by 1 here. Okay. So normal chain rule, I just multiply that. So you got u is x minus 2, u prime is 1, f of u is u to the negative 2, f prime of u is negative 2u to negative 3, f prime of x is negative 2, x minus 2 to negative 3. So negative 2 times negative 2 is 4, and that's what you get. Okay, zeros. Numerator equals 0. There's none. Undefined, that's when you set whatever's in parentheses. You could do x minus 2 cubed in parentheses, but if you cube root of 0, it's just going to be 0. So x minus 2 can't equal 0. Okay, we're going to test that point. Negative infinity to 2. F double prime of 0 is going to be 0 over a negative. So we got 4 over 0 minus 2, which is negative cubed is a negative. Zero minus 2 is negative 2. Negative 2 cubed is a negative number. F double prime of 3 is going to be a positive because you got the 4. There's no x there. Positive over 4, or 3 minus 2 is 1. Cubed is a positive number. So we do have a point of inflection at 2, and the concavity is changing because you got concave down there, concave up there. So this is concave down, concave up. Point of inflection is going to be at 2, f of 2, which is going to be a vertical asymptote, which we already figured out here, because if you put 2 in here, you're going to get that. Remember, x can't equal 2 because it's a vertical asymptote. So it's decreasing from negative infinity to negative 2. And concave down. And then it's decreasing again from 2 to infinity, but it's concave up. There you go. I don't know why that's so dark today, but hopefully you can see. Okay. Alrighty. You can keep going for another one. It's a long one, but I'm sure we will be fine. Okay? So let's go. Okay, so this is going to be f of x equals 2 x to the 1/3 plus x to the 4/3. Okay. So the domain is negative infinity to positive infinity. No radicals, no denominators. Zeros. So let's look at zeros. So 0 is 2x to the 1/3 plus x to the 4/3. Greatest common factor is going to be the lowest one. So that's going to be, the lowest is 1/3. So you get 2 plus 4/3 minus 1/3 is 3/3, which is 1. So x to the first. X to the 1/3 equals 0. 2 plus x equals 0. So you got x-intercepts at 0 and at negative 2. Okay. Y-intercept is going to be at 0. So you got 0 and negative 2. First derivative. I'm just going to go up here from there. F prime. That would probably be easier if you did the product rule, though. Yeah, let's go ahead and do the product rule for the first derivative. I'm using this one. So f is x to the 1/3. F prime is 1/3 x to the 1 minus 3 is negative 2/3. G is 2 plus x. G prime is 1. So that's going to be f prime of g. So 1/3 x to the negative 2/3 times 2 plus x plus x to the 1/3. Okay, now you're going to have to greatest common factor that. So the lowest one is negative 2/3. So you're going to have 0 x to the negative 2/3. So that's going to be 1/3 times 2 plus x. 1/3 minus a negative 2/3 is going to be 1/3 plus 2/3, which is 1. Which is going to give you 2/3 plus 1/3 x plus, I'm going to go and do a common denominator here, 3/3. So 0 equals 1/3 plus 5/3. Okay. I guess you could take out a 1/3, but I'm not worrying about it now. Okay, so zeros. 1/3 x plus 5/3 equals 0. So you're going to have 1/3 x equals negative 5/3. Cross multiply, you get x equals negative 5. Undefined. Are going to be x to the 2/3. So x equals 0. I'm going to redo this problem on another video, but I believe I gave you a good start on how to connect everything. So yes, so stay tuned. This problem will be on another video. Okay, sorry I couldn't finish it now, but I have to go. So bye.